We are trying to build a Tony Stark AI, not a fake one, but a real one from the Ironman 1 movie. The whole purpose is to get the full out GUI, full out natural language processing, the actual general language modeling that goes on behind the scene, that dynamic GUI changes on the page, and last but not least, the actual voice communication back and forth. Today, in the second video, we are looking at neural language processing. Take a moment to like and subscribe. Let's get started. Last time, we talked about creating a GUI like Jarvis. Now, we're talking about the first version of NLP with Jarvis.
Yes. Shall I render using proposed specifications?
Natural language processing is hard because it's difficult to make a machine talk. There are various ways to think about this and tools that we could use. To make this anything like Jarvis, number one, the machine needs to fully understand who is speaking.
Tonight.
The render is complete.
A little ostentatious, don't you think?
What was I thinking? You're usually so discreet.
Number two, needs to understand something about the person it is speaking to in order to make a connection and be able to relate.
I'd like to open a new project file, indexed as Mark II.
Shall I store this on the Stark Industries central database?
Actually, don't know who to trust right now. Till further notice, why don't we just keep everything on my private server?
Working on a secret project, are we, sir?
Number three, it needs to generate some text that is extremely relevant and contextual. It cannot give canned responses. I had to stop for a moment and upgrade my gear. I had multiple computers running and I needed to view them in real time. So I got a pretty large monitor to help with splitting the screen to show both computers. First thing I did was have meetings with my friend, Jorge. Jorge is a computer engineer. He helped with some of the design work and he reviewed the natural language model that I proposed. He showed me some of the flaws in my model and ways to help improve it. After reviewing the design, I needed to find a way to convert words into context and then take the context to generate words. So first I looked at converting words into context. I noticed that the way many people did this was to take a bunch of A to B conversations and try to use the individual word tokens to determine the answer. Even though this seems to be general language modeling, this is still narrow AI because we still are attaching A to B. This helps create structure and probably reduces noise, but it becomes too rigid and hard to scale. So I focused on creating a general language model in Jupyter Notebook that takes in bodies of text from different sources. I keep the topics relatively similar. I concatenate this into a very large body of text. I broke the text into fragments and I trained on this. I still need to work on this model. It's relatively slow because it's nearly 200 million parameters and I don't have the compute speed or the cost and money to keep running this. So the way to represent this model needs to be evaluated, but for now, it works. So next, I needed a way to bring this all together. So I did the unthinkable. I used GPT-3. Hold on. I used GPT-3 to make or take the fragments that were output from my model and smooth out the words. I'll say this. Why do I need to create an actual word generator? When GPT-3 does it well, I don't have to spend $5 million to run a model like this. And honestly, why do I need to build it when I can use the API? The magic is not in the OpenAI's GPT-3 model, even though it does a really good generating. The magic is building a model that truly understands context and tries to respond on that. I'll say this, that the GPT-3 was an interpreter on what my model was trying to say.
Shall I render using proposed specifications?
Roll me.
Overall, I will continue to work on this, and much improvement must be made in the further revisions. Thanks for watching, and let's get the dynamic page generation working from our voice conversation. Have a good day.